So we're in ancient Athens today, and I wanted to take this opportunity to ask Henry a bit about the history of maths, because it obviously originates from ancient Athens. So
Geometry. Not
geometry.
all mathematics.
Okay.
There's a lot of good algebra from the Babylonians.
But in terms of geometry, so obviously that was used for all of the buildings, all of the architecture that we see that are now ancient ruins. Can you explain a little bit about who the main characters were in that story of building the geometry that we now know so well today?
Well, the main characters are, of course, those from history, right? So, history is everything that has a written record. So, we know about Plato, who's famous for his geometrical objects, and he wanted to uh, find the minimal building blocks of the universe, kind of like atomism, but it's known as Platonic. It's his idea, um, and and because it's an idea, it starts with it's almost religious. So he had a school with him, and they had a sort of spirituality around numbers and the numbers describing our world. Um, and that's because, take music for example, there are certain harmonics. An artist or a musician knows that when they begin, um, maybe they choose the canvas or the first notes, but then everything else follows logically. And so it's not so much that we just create, we discover patterns when we're being creative. Um, and so they stumbled across these patterns, and for them it was the sign of a sort of imprint to the universe, as if they didn't have a god, there wasn't a deity as such, but they did have some sort of spirit, right? It's a spirituality. um
Yes, and we notice lots of patterns in Greek architecture. Like you've got the Greek key, and in the columns, you've got all the different styles. You've got the Ionic, the Doric, Corinthian, and there are other patterns as well that we've noticed on some of the rooftops and the friezes of the buildings. So it really, what you're saying is that it really was all about patterns.
Patterns are very nice when you discover them. Those harmonics, they're very nice mentally. um right, classical music is played to babies to make them more intelligent, or is played in cafes to relax you. Um, it's known as euphony, in opposition to a cacophony, uh, loud noise that irritates the ears. So there is something to the harmonics. And of course, if you're not distracted by phones and other cacophony, then then you're going to find ample time to just notice patterns. You take the trees around us, uh, you can kind of imagine, although they've got all these forms, and the artist might emphasize those forms, um, the mathematician might come along and go, oh, well, they're kind of like a line. And he'd be interested in the question of, why aren't they quite a line? And can I quantify that in some way?
So, who was the founding figure of such work on patterns and harmonics in ancient Greece?
So Plato is the
Plato.
famous name.
Hmm.
Yeah.
But how did he make these discoveries? Just by being curious and just trying different things out?
Yes, there was experiment, but it wasn't necessarily scientific experiment like we do now. They emphasized thoughts, so it was thought experiments, um, and specifically through a process known as dialectics. So dialectics, dialect, talking. It's not just talking. It's not discussion. Um, we're having a discussion now, uh, but Dialectic is when one person steers the conversation. So Vicky's asking me the questions, but you don't know the answers, so it's a discussion or an interview. But a dialectic would be me prompting the questions you should ask and trying to steer you. And if you ask the wrong question, explaining why it's wrong. We've all done that. Sometimes you just ask the wrong questions when we're learning.
So Plato would have been engaging in a
In
dialectic
in a dialectic, yeah.
with other philosophers or just other people in the city?
Yes, other philosophers, very famous, and his students. Yeah, and so he had an entire school, and the idea was that at every level you teach the level below you, and so the whole dialectical school was every level interacting with the level below, sort of thing. Yeah.
And so he built this school up on his own accord, and he would teach people geometry and he would teach people maths.
Yes. So you have Socrates, who's famous for never writing, and then I believe he taught Plato, and then Plato wrote these things down.
And you've got Plato's Republic now, right? It's a book that
Yes, that's
some
his most
people might
famous.
choose to read. Some people might be slightly put off, like myself.
Right. So basically, Socrates. No, it's not so bad because it's dialectical. So it's him going around ancient Athens, and asking people questions. So we've seen before that they had these large buildings that would keep them cool in the heat, and they would just walk in them. Sometimes they'd also have these conversations in the temple, in the marketplace, and they would just sort of walk.
I guess the meeting houses.
The meeting houses, and
just built on the slopes of the Acropolis. And that's where they would meet. They would all come together.
Yeah, and so he would ask people questions like very simple ones, like "Why are you going to work?" and they couldn't answer. Why are you doing this? Why don't you do it like that? Why do you do why do you do this and not that, basically all the time. Obviously sometimes it didn't go down too well, and of course that led to the famous death, murder of Socrates.
He was murdered.
Yeah, exactly, because he was asking all these questions, and so they were considered to be like inciting the young. Yeah, because you ask all these questions, and you know, that's revolutionary. You get people thinking in a new way. Well, they might not like the way things are. If they question why things are the way they are, they might want to change things. And so it it revolts against the powers that be.
So this is how they came up with lots of geometric principles.
Right. Well, you need to. We'll take a pause here because there's a bit of a crowd. Okay, so it's quietened down a bit now. And you were just asking me why geometry, why all this focus. So to Plato and their school, it wasn't considered the most important thing, but it was considered an essential part of the philosopher's education. So any lover of knowledge is education. And the idea is you need to think logically. So maths is a great like place to wrestle with logic. They would also deal with logic directly, but geometry specifically, you're trying to look for patterns that don't actually exist in the world. They exist in your mind. So a straight line, you can never find a straight line because everything is bent. If you measure it finely enough, you'll find it's bent in some way.
But we're not looking at things on that level.
Not at that level, right? Right. But so the world itself doesn't have a straight line. Or for example,
That seems really hard to believe.
well, for example, he had an idea of forms.
Hmm.
So the world has many examples of trees, but does it have a tree? What is it about humans where we can identify these are all trees?
Hmm.
These are all stones.
Well, you've just defined them.
So, for example, to what extent is a chair no longer a chair? If I remove the back, it's a stool.
Hmm.
So Plato thought that that meant that there are some sort of forms,
Hmm.
and he thought uh, basically that's his sort of spirituality, that there's this universe of perfect forms, and out of it comes our imperfect world.
But there has to be straight lines because we use straight lines in architecture. Otherwise, buildings would not stay standing.
Right, but if you measured them, uh, with a microscope, you'd find you'd find that even the atoms aren't quite aligned perfectly straight
Hmm.
sometimes.
Like if you were cutting glass, for example.
Yeah, if you look finely enough, you'd notice some sort of like kind of bulge in places.
Hmm. And that's true for the marble that they were using to build some of the monuments, like the Acropolis and things.
Yeah, I mean, I don't want to wrestle with these ideas too much because they're old, and today we understand we've been able to do more philosophy since, and the result of that is that although he thought that there were these perfect forms out there, today we just see that as an anthropocentric phenomenon. Um, in other words, it's just because we're human and we think the universe revolves around us that if we see a tree, there must be a perfect tree somewhere out there. No, no, it's just we identify it.
Hmm.
So it's just a labeling system.
Hmm.
Why is a chair different from a stool? It's just labeling. And if you really want to relabel things, bread could be a spoon in a restaurant
Hmm.
because you use it to mop things up.
Yeah, that I can see that.
So Plato hadn't thought of these sorts of things.
Hmm. But what is one of the geometrical formulas that we use today that was founded by Plato?
Oh, so right, they weren't really engaged in formulas as such because they didn't have algebra, which came from, um, well,
Ancient Egypt.
some of it came from the Babylonians. Um, it's from the Arabs, so it's all over North Africa and some of the Middle East.
Hmm.
Yeah, uh, I
Okay.
don't know the details of that, but that would be interesting.
So they
But
weren't using formulas, but what were some of the
right,
basic principles that they were developing?
well, so they were developing principles and a methodology. So what they wanted was basically axiomize the world. So can we find the first principle behind everything? Right. So let's say I have two straight lines. They never meet. So I can say straight lines never meet.
Hmm.
Right. I can just do it with like straws. And then can I prove that? And so they would basically they decided that the way you prove stuff is you need a compass and a ruler, a straight edge. And the compass today, obviously, we've got these plastic things. Um, for them, it was literally just a string with a pencil, and then you could just, if you take the string and you stretch it out so it's taut, you can draw a perfect circle.
Hmm.
And then you can do things like if I take a line and then I draw a perfect circle around it, and then I draw another point from another point on this same line. I draw another circle which crosses the first one at 2 points. That actually defines the 2 points of a line perpendicular to the first.
Hmm. So really, they were just building the foundations for some of the tools that we use to measure geometry today. Right, that is an early protractor, for example.
Right.
They were just using the basic tools that they had.
Yeah, exactly. And that would have been really useful for then being able to draw a perpendicular line to the first, which is essential for building what they did, right? So they were excellent geometers, and their mathematicians, which were also philosophers, were interested in uh, can I reduce the number of assumptions? Or, for example, if I have a bunch of mathematical tools, can I derive them from a smaller set?
Mm-hmm.
So it's packaging up your knowledge from, oh, this is funny, like this is a useful trick. So it's packaging it up from tricks to a framework based on a small number of axioms, and from them you can derive all the tricks,
Mm-hmm.
which is quite satisfying. But moreover, it means if you want to preserve your knowledge, if you just preserve the axioms and then the method, then people can rederive all the tricks when they need them later. Um, it also means that people's, uh, mind, their network architecture is more structured, which makes it easier for people to think, to have insights, to have less overhead when they're thinking, because everything's more connected, and connecting in knowledge is precisely what gives you all of that.
So obviously all these ideas of geometry were preserved and were carried forward to the next generation and so on. How would have this have been done? Was it documented in any way, or what enabled us to know today what they knew back then?
Yeah, they wrote it all up. I mean, they were in trade with the Egyptians, so I suppose they must have had paper records and things like this. But I don't know the details of that. What I do know is uh, a great part of the preservation was monks across Europe uh, rewrite, copying books, um, and that was the only way knowledge was preserved. And also, it would hide in monasteries for a long time until somebody rediscovered an old book. Um, that was, for example, what led Dark Age artists to begin to refine their artwork, um, or accelerate in their refinement, because they saw ancient artwork that had proportions, and their paintings didn't have proportions. So a civilization before them knew more than they did. Oof. So they had to find out what that was, and it turns out it's an entire mathematics known as projective geometry, which is still widely used today, is actually the background of all of quantum mechanics, which many people don't know, by the way. Um, Very powerful stuff. For example, uh, if you take, so Euclid was another geometer, and like say you take a farm, you divide it up in a square, then obviously the two sides are parallel, so they don't intersect. And yet, if you look at it, so me right now, my two arms are parallel, but you looking at me, my hands are closer to you than my elbows, and that means that my arms are actually converging in some sense towards you, and that's known as projective geometry. Yeah, these points of convergence. So in projective geometry, parallel lines always intersect.
Hmm.
Yeah.
And is there any geometry that we don't understand, or do we know all of it?
Oh, well, we've generalized the whole thing to just unbelievable levels. Um, so, so you had Descartes who came in, and he made it Cartesian, named after him, Descartes. Um, and he refined the whole thing so that I don't know that they were quite thinking in this way, But in modern terminology, he basically turned geometry into something you could almost calculate on a computer. He built, um, uh, let's say, he put a coordinate system on the Greek geometry. So now you could actually have a blueprint of whatever you were building on a grid. And then you could just do the measurements without comparing straight edges. Like, you would just read the grid. So that was very powerful. He also brought in, yeah, we attribute it to him, but there were others involved. Um, but he sort of formalized trigonometry into this whole um, grid system. And so now you could have really precise maps. So the Portuguese Empire basically was single-handedly brought into existence by trigonometry, because now you could actually use the stars and your mathematics to navigate. Um, and then the British Empire, a big part of how it conquered the world was not only through um, trigonometry in naval navigation, but also on land. They built these really precise, what are known as ordnance surveys, just the most precise maps the world had ever seen. Um, so yeah.
So you briefly mentioned quantum mechanics. What are the ways that we can use geometry for the future?
Oh, for the future, just go back to the basics and really understand basic concepts of geometry well. Because if you enjoy that and you enjoy seeing the geometric structure of our reality, then you're gonna really enjoy quantum mechanics. Um,
How would people do that? How would they really uh, learn the fundamentals of geometry well?
yeah, so you need the convergence of three things. You want geometry, so you want that mathematical visualization. Two, you want algebra, so you want to be able to see that same geometry in terms of equations. And three, you want to see it in real life. You need an experimental setup. I'd say the best place for that is waves, pressure waves, acoustic waves. You get to see the convergence of trigonometry describing the waves, which is a form of geometry. You get algebra describing the equation of said wave. You get to learn about harmonics. Um, it's fabulous. And moreover, you learn why when you're driving down the motorway, sometimes the radio goes dead silent. Or in some areas, your mobile might go dead signal.
Mm, mm.
Why does that happen? Because two waves have deconstructively interfered at the specific point you're at. And so it explains the world through a purely uh, wave picture.
But how does that relate back to geometry? A wave is a geometry, or
It's a basic form of geometry, because you can draw a wave out, then you can put it on a map. So it's an early form of geometry, but it's also came much later in history. You don't have to start with the basics. Um, you just want to ask very basic questions about whatever you're looking at and go down from wherever you're at.
Mhm. So to finish, what's your favorite geometric principle?
Oh,
Do you have a favorite?
well, I have so many.
But if you just had to choose one.
I think the fifth Euclid's fifth postulate, which kept mathematicians busy trying to prove it for well over 1,500 years, is a really interesting one. They wanted to prove that straight lines never meet, but on Earth, what they didn't realize is because the Earth is a sphere, they have to meet in two places exactly, which we label as the poles, but that's arbitrary.
Hmm. And obviously, in the world of design, people have to use geometry all the time. Architects, designers. But are there any new ways, do you think, that we can use geometry in the things that we design? Do you have any ideas about that?
Yeah, so geometry in terms of how to manipulate the material is already well done in terms of glass and plastic. Um, but if you want to do something that I think is probably less charted territory, I'd say manipulating light geometrically. So what I mean by that is, again, anthropocentrism. We always see the world as we see it and think we're the center. So we are always interested in when light converges at a point, um, because the light has to converge at a point in our eye for us to see the world. But when, and of course, when you are in a theatre and you've got the film projected on the screen, again, all of this needs to be converging at the precise point. Otherwise, it would look off.
Like 3D. That's why you have to wear 3D glasses.
Yeah, but in this case, it would just look out of focus. So we throw away light, which is out of focus in some sense, because it's no good. Well, what I'm saying is, don't reject it. Give it some love. There is an entire world of patterns of light which is slightly out of focus, and that's known as acoustic. And the most familiar examples are at at the bottom of a pool, a swimming pool.
Yeah, you get some really interesting reflections.
Yeah. So those reflections are known as caustics. You also on top of the waves in the water, especially in the sea, when it's all sparkling. That's another form of caustic. It's a reflection. And if you have a glass, you'll find some really beautiful caustic patterns. And I'd say designers can really do some interesting things there. And like optics is a huge area of research, so they could do some very cool stuff.
That's awesome. Great. Well, I've enjoyed this chat, and I feel like I have much more of an appreciation now for the geometry that was founded in ancient Athens and how we can use it for the future as designers, as creative beings, and as scientists. Of course, you'll be continuing to use it in your work.